Hello everyone, my name is Amit Singh and I am from Madan Mohan Malviya University of Technology, Gorakhpur, India. For today's conference, my topic is Emerging Challenges of Environmental Issues in Hilly Snow-Covered Areas of North Western Himalayas. As you can see in this slide, we are going to talk about all these contents in our presentation. Now let me introduce about the area of study which I have chosen for my research, Himalaya. Himalaya is the world's third largest glacier mass after Atlantic and Arctic glaciers. In this study, we choose to cover only Indian Northwestern Himalayas, which covers approximate area of 33 million hectare and is located in 3 states of India, Jammu and Kashmir, Uttarakhand and Himachal Pradesh. The Himalaya on the northern fringe of India is just one of the absolute most essential mountain ecosystem in the world, which homes the biggest snow and ice cover outside the polar region, often termed as the third pole or even water tower of Asia. The region is source of a few big river systems of Asia, like Indus, Ganga and Brahmaputra. Substantial percentage of entire world occupies the good Gangetic plain and rely on water from those sources. These hills indirectly or straight impact life and livelihood of more than 300 million persons. Himalayan mountains are important for amazing wealth because this area was declared among the 3/4 biological hotspots in the world. Socio-cultural motto exhibits a fantastic variety in the whole arc of Himalaya. Also is administered by various political divide involving 2 inland states, Nepal and Bhutan, and assorted states of India along with China. Now if we talk about the history of Himalayas, the Himalayan and its nearby high altitude regions are the vital source of major river system in India, together with Ganga, Bias, Brahmaputra, Indus, Chenab, Jhelum, etc. As huge areas of Himalayas are covered by snow and glaciers, these areas plays a crucial role in regulating the climate change seasonally as well as annually. Himalayan region are very susceptible to climate change if we study its climatic condition in terms of large-scale warming. The ice accumulation present in this particular region is the world's third largest on Earth after Antarctic and Arctic ice mass. Some current assessment has shown that warming and fluctuation of heat in Himalayan area is mounting rapidly as compared to the global average over the last few decades. The main objective of my study is to determine the amount of change in snow cover area of Northwestern Himalaya using QGIS and ArcGIS software, and to compare the snow cover status and plot variation through digital image processing, along with assessment and forecasting of snow melt discharge after winter month, which are November to March. From this study, we will get benefit in space-based remote sensing has improved the capability of mapping and monitoring. It gives us a snow cover area with high temporal and spatial resolution. By using QGIS software, we are going to get more accurate and more precise data for our calculations. Now if we talk about the principal methodology for snow cover area extraction, that is actually the Mod10A2 product used in the study gives 8-day combination of the snow cover area and also the 8-day highest snow extent on tile of Mod10A2 comprises of 2400 by 2400 lines and sections with 500 M pixels and is accessible in sinusoidal guide projection. These data sets are normally coded by each land spread. Since the pixel esteem for the snow secured pixels is a steady worth, the procedure of extraction of snow spread zone can be effortlessly computerized. The procedure of snow spread mapping gets troublesome on account of presence of cover over the snow secured region for longer length. In such cases, the zone will be coded as cloud in MODIS snow spread item. So MODIS is one of 4 sensors carried on board NASA's first Earth observing system. That is actually EOS satellite, which is known as Terra. There are 2 kinds of satellites, Terra and Aqua, but we are considering for Terra satellite. The automated MODIS snow mapping algorithm uses satellite reflectance in MODIS band 4 and band 6 to calculate the NDSI value. The main limitations of our study is snow is assumed to be present if NDSI value is greater than 0.4, and for overcome this limitation rule-based algorithm was produced and implemented by Hall et al. 2002 using MODIS sensor onboard Terra and Aqua satellites. Now we are going to tell you about the data used from where we have used our data. The MODIS temporal snow cover information depend upon a snow mapping algorithm that to a great extent uses NDSI. The NDSI appraisal is unwavering by the help of reliance reflectance in MODIS band 4 and MODIS band 6. The actual type of cell as snow and non-snow is decided on the basis of NDSI value. the reflectance in MODIS band 2, as well as NDVI values for vegetation areas. The NDVI values are determined in comparative way as the NDSI using reflectance in visible red and near infrared bands. Weekly snow cover maps are prepared using NDSI method over daily MODIS data on board Nova Terra are available in public domain from 2000 to present date. Same have been used to plot map and calibrate the status of snow cover in North Western Himalayas. In our present study, the winter seasonal months, November to March months, MODIS snow cover product MOD10A2 has been analyzed using automated snow cover extraction tool. Weekly snow covers data of each winter season from 1 November to 30th of March has been analyzed, and status of each northwestern Himalayan sub-basin has been calculated and compared. The bi-monthly snow cover maps are developed by the help of AYFS data available on Bhuvan has also been used in this study to calculate the total area under the snow. Now if we talk about the observation, you can easily see here the data of 2019 and 2018. There is a comparison between the snow cover area status in first week of March in 2019 and in 2018. And after that you can see the percentage increase in snow cover area of early spring season in year 2019 with reference of 2018. As you can see here, sub-basin regions are Gilgit, Ara, Beas, Chenab, Jhelum, Lower Indus, Ravi and many more. Here you can see our calculation of average snow depth and temperature graph is plotted, where maximum is represented in old grey and average in new black. You can see from graph that 2010 to 2020 we have plotted all snow depths, and at the top of our graph you can see red, blue and dark blue lines which represents mean temperature, minimum temperature and maximum temperature. If we talk about a snow depletion curve, here we found that heavy snowfall years are 2011-12, 2013-14 and 2018 and 19. On the basis of that, we developed the derivation of a snow cover depletion curve. Here we have maximum, minimum and mean snow depletion curve. In our study we used the most left curve you can see here, as the curve goes to the left, which means snow melts slowly. Now we came to the results. MODIS 8-day maximum variation from December to February. Here you can see the temporal change in snow cover during winters. You can see here 25 November to 2 December, 25 November to 2 December, 2nd of December means 8-day. It is actually 8-day maximum variation. You can see after that we got the maximum on 9th to 16th Jan of 2020. After that we got from 10th to 17th Feb 2020. These are the 8-day maximum variation which we obtained from December to February in the year of 2019 to 2020. If we talk about the snow cover area, maximum snow cover area we have observed in the first week of March. As you can see, the snow cover area in the first week of March of 2019 is slightly less as compared to the snow cover area in the first week of March 2020. That is actually the 10% increase has been observed in northwestern Himalaya. The snow cover area is increased by 10%, which is actually obtained by the help of ArcGIS software. Here in this map you can see that this is the temporal snow cover map which is developed by the help of NDSI values. So we developed our map on the basis of maximum temporal snow cover for the first week of March 2020 and for the first week of March 2019. If we are talking about the stream flow considering the snow melt parameter for the year 2017 and 18, this graph can be used for the forecasting of the stream flow. As you can see here for the peak months like from March, where in India summer starts, you can see there is an increase in the stream flow which shows that melting of snow in the month of March, April, May, and it slightly increases. And if we talk about same in 2018 and 2019, we got increase in the month of March, April, May, June, and this increase continues. So this graph can be used for the forecasting of stream flow in the year of 2020. Now if we talk about some results of MODIS and AYFS snow cover area analysis, we found a gradual percentage of mismatch which is actually on 29 Jan 2020, 10th Feb 2016, 11th March 2018, 27 March 2017, 30 March 2018, 26th April 2019 and 1st March 2017. These are some percentages of mismatch where we found the maximum percentage of mismatch is on 1 March 2017. Here we have the MODIS and AYFS snow cover area, and we also mentioned that what kind of snow type was there. So let's come to the conclusion. We got the 10% increase of snow cover area has been observed at North Western Himalaya in the first week of March 2020. By the help of that graph, we can predict that the increased snow cover snow depth will produce higher snow melting during upcoming spring and summer seasons. And I think this will require proper planning, including hydrologic forecast will lead to increase in hydropower generation and reservoir storage. These are some references over which I took help throughout my studies. I would like to thank all of them for their kind attention. If you have any query, any questions, you can contact me on my email address. Thank you so much.